Hi, physics students. Welcome again to another fun flip video with Mr. Bo today. Today we're going to be looking at a kinematics problem for free fall. So a free fall problem involving our friend Jay Cutler. So let's take a look at the problem. It says Jay Cutler tries to throw to Alshon Jeffrey but gets hit before he can make the throw. No big surprise there. Consequently, he ends up throwing the ball straight up in the air and it is caught by the other team. We're going to assume it gets caught by the other team at the same height that he threw it from. Assume it is caught at the same height which it was thrown. Okay, so let's jump right in. What is the first thing you should always do when you're solving any sort of a physics word problem? Draw a diagram and put 0, 0 in your diagram. So here we go. We'll say here's the ground, here's J, like that. Here's the football, and the football is going to go up to the apex and come right back down, and it's going to get caught at the same height that it was thrown from. So just like that. Now we want to put our origin 0, 0 in there, so let's say that 0, 0 is right here where it starts, on the ground, or from his hand, where it leaves his hand. Now, the first thing this problem asks us to do is to sketch a position versus time and a velocity versus time graph for the motion of the ball. So here's going to be our position versus time graph, like this. It's moving in the y direction, so I'm going to call the position, use the variable y versus time. And what we can do is we can describe it in words. As the ball rises to its apex, it's moving in the positive direction, slowing down. So moving in the positive direction, slowing down is going to look like this. And then as it falls from the apex, it's speeding up, moving in the negative direction. Moving in the negative direction, speeding up looks like that. Then our velocity versus time graph for the ball is going to look like this. Again, it's moving in the positive direction, speeding up. Moving in the positive direction, slowing down, and then moving in the negative direction, speeding up. So moving in the positive direction, slowing down is going to look like this, and moving in the negative direction, speeding up is going to look like that. And we see that at the apex, our velocity is 0 meters per second, which makes sense because the ball stops for a split second when it reaches the apex. Now, it then goes on to ask us to find some things about the ball, some values. If the maximum height of the ball above Jay Cutler is 3.5 meters, calculate how fast Jay Cutler threw the ball. That means like the initial velocity from his hand and the total time the ball is in the air. Be careful, that's not just asking for the time to the apex, that's asking for the time to the apex and back down. But we know that there's symmetry there. So the time to the apex, if we double that, that would be the total time, because the time up is equal to the time down. The next step in solving a problem, a word problem like this, that I've talked to you about a whole bunch, is to list your variables, okay? So let's list our variables. We'll do that right here. Position initial, position final, velocity initial, velocity final, acceleration, and time. I just want to say again that if you don't list your variables, you're missing out on a really important step. Now, you also got to label where you're going from and where you're going to. So in this case, I think I'm going to list, because we know that it reaches a height of 3.5 meters, I'm going to say that we're going from his hand to the apex. So you got to be clear about where the start and the end is, the initial and the final. Okay, now that we've done that, we can fill in our values. It initially starts here, so its initial position is a height of 0 meters. It rises up there, which we know is 3.5 meters, so it rises to a height of 3.5 meters. Its initial velocity, we don't know how fast Jay threw the ball. Its final velocity, well, that's at the apex, and we know at the apex, it comes to rest for a minute. Its velocity at the apex is 0 meters per second. The acceleration, we know, as long as only gravity is acting on an object, it experiences an acceleration of negative 9.8 meters per second per second. And we don't know how much time it takes to reach that apex. But we have enough variables that we can solve for our unknowns, these two unknowns. So we got to pick an equation. I'm going to go ahead and initially solve for the initial velocity. And I'm going to do that by picking this equation. So it's always a good practice to write that equation out. Final velocity squared equals initial velocity squared plus 2a position final minus position initial. Then, as I've said in the past, the next good step is to cross out anything that's a 0. So let's see, in this case our final velocity is 0 and our initial position is 0. So that's going to simplify things. That means 0 equals the initial velocity squared plus 2a times the final position. I can subtract my initial velocity squared over negative initial velocity squared equals 2a times the final height. don't be scared of that negative sign. Sometimes students see these negative signs in there and they get worried. They're like, ah, what's going to happen? If you list your variables correctly and you put the correct positives and negatives in front of them, negatives will work their way out appropriately. Okay? So now we can plug in our values. So this is our question mark. So negative v initial squared equals 2 times the acceleration, which is negative 9.8, times our height at the apex, which is 3.5 meters. So you multiply all that together, and you're going to get negative 68.6. So negative v initial squared equals negative 68.6. And you might be worried, oh no, I can't square root a negative, but what did I say? The negatives work themselves out. These two cancel with each other. So we take the square root of 68.6, and we find that that initial velocity was 8.3 meters per second. So the initial velocity of the ball was 8.3 meters per second. So now it asks us for the second part to find the total time that the ball is in the air. I can do that right here, I think. So we're going to pick the equation, this one right here. The final velocity equals the initial velocity plus acceleration times time. Let's cross out anything that's 0 because we're going to the apex. We know that our final velocity is 0. So we see that 0 equals our initial velocity plus acceleration times time. We subtract our initial velocity over. Negative initial velocity equals acceleration times time. We're trying to find that time. We can plug in our numbers now if we'd like. Our initial velocity, we just found that to be 8.3 meters per second. So negative 8.3 meters per second equals our acceleration, which is negative 9.8 times time. We divide that negative 9.8 and we find that the time to the apex is going to be 0.85 seconds. Now, I shouldn't box that actually. Let me unbox that. Here we go. Because that is not the total time that the ball is in the air. That is the time to the apex, but not the total time that the ball is in the air. The total time the ball is in the air is twice that. So twice that is going to be a time of 1.7 seconds. There we go. So Jay gets hit, he throws the ball straight up in the air, it rises to its apex in 0.85 seconds, and it falls from its apex in 0.85 seconds, which is a total time of 1.7 seconds. Hope that helped you out. Good luck doing the rest of the homework. I'll see you tomorrow.